Scientific theory. When a hypothesis or group of hypotheses have been provided by various independent groups of researchers at various times, the hypothesis is accepted as a scientific theory. To scientists, a theory is coherent explanation for a large number of facts and observations about the natural world. A theory is 1. Internally consistent and compatible with evidence. 2. Firmly grounded in and based upon evidence. 3. Tested against a wide range of phenomena. 4. Demonstrably effective in problem solving. In popular use, a theory is often assumed to imply mere speculation, but in science, something is called a theory. Something is not called a theory unless it has been confirmed over many independent experiments. Theories are more certain than hypotheses, but less certain than laws. It is often said that theories can never be proved, but can only be disproved. This is because there is always the possibility that a new observation or experiment will be in conflict with a long-standing theory. This conflict often leads to what is called paradigm shifts. Scientific law. The overwhelming evidence is obtained over a long time to support scientific theory. The theory becomes a scientific law. A scientific law is a description of a natural phenomenon or principle that invariably holds true under specific conditions and will occur under certain circumstances. The scientific revolution. The period called the scientific revolution also embraced the Copernican revolution, which is the name given to the period during which the theory of the solar system and the wider cosmos, which had the earth at the center of everything, geocentrism, was replaced by the theory that the earth revolved around the sun, heliocentrism. From philosophical point of view, the most important development during the scientific revolution was the increasing widespread break in the theories of Aristotle. That's 384 to 322 BC. History of science. The term science is a Latin word for the knowledge, scientia. What we today refer to as science was until 1840s called natural philosophy of pre-modern science. For a true understanding of where we are in science today, no one needs to look at what happened in the past. The history of science can teach us many lessons about how science should and should not be practiced. It can also help us to understand the direction in which science is heading to today. Without a historical perspective, however, you will not fully appreciate what science is. The presentation of history will be presented based on different periods. Now let's talk about the emergence of science, which happened between 600 BC to 500 AD. According to history, the first true scientists were ancient Greeks between 600 BC and 500 BC AD. However, before them, many cultures like the ancient Egyptians, Mesopotamians and Chinese have collected observations and facts, but have not tried to use the facts to develop explanations of the world around them. Thales, Anaximander and Anaximenes stood out among the Greek scientists. Thales studied the heavens and made effort to give an explanation for the movement of the heavenly bodies, that is, the planet and the stars. He was able to correctly predict short-term disappearance of the sun, which of course was the solar eclipse, an event in which the moon moves between the earth and the sun, mostly blocking the sun from view. Anaximander was the first scientist who tried to explain the origin of human race without reference to a creator. He explained that all life began in sea, and at one time humans were actually some sort of fish. Charles Darwin later restated the idea, and it is today called evolution. Anaximenes believed that air was the most basic substance in nature. In fact, his belief was that all things were constructed of air. His thinking was that air is thinned out, it grows warmer and becomes fire, and that when it thickens, it condenses into liquid and solid matter. These ideas were found to be nevertheless be wrong. His attempt to explain all these things in nature has been made of a single substance led to the concept of atoms. Leucippus, another Greek scientist who built on the concept of Anaximenes and proposed that all matter is composed of little units called atoms. He is known as the father of atomic theory. Three other notable scientists from Greek during this period are Aristotle, Archimedes, and Ptolemy. Aristotle's greatest work was the study of living things. He was the first to make a large-scale attempt on the classification of animals and plants. Although Aristotle was known for a greater number of wonderful advances in science, he was also responsible for a great deal of nonsense that hampered science for many, many years. For example, he believed that certain living organisms spontaneously formed a non-living substance. Imagine. This idea was called spontaneous generation. The idea is that living organisms can be spontaneously formed from a non-living substance. For instance, human being can be formed from telephone. Archimedes is best known for his work with fluids when he showed how one could predict whether or not an object will float in liquid. Ptolemy studied the heavens and assumed that Earth was the center of the universe and that the planets and stars orbited around the Earth in a series of circles. The system is called geocentric system. In this system, the Earth sits in the center of the universe and does not move. This system was considered to be the correct explanation for the arrangement of planets in star space until about the 70s. Next, we'll talk about dark ages, which occurred from 500 AD to 1000 AD. Hope you had a nice time learning this.